Continuing our discussion of the Linux stack protector, we're looking at the difference between the stack here when there is no protector and here where we do have this protector. So what's the difference? When we have a stack protector in use, there are a couple of things that come into play. The first is something called a stack canary. Now, the early attempts to get rid of all of these stack buffer overflow vulnerabilities attempted just to insert a canary. Now, if you're familiar with mining operations, which I'm guessing many of you are not, they used to have canaries in the mines. And the idea is that the canary would die first. If there was some sort of problem, lack of oxygen, some sort of toxic gas, it would kill the canary first. So if the canary died, everyone would immediately get out of the mine. And the idea of a stack canary is that if someone overwrites the stack canary, then you know that somebody is tampering with the stack. And you can say, well, I am going to abort. Now, early attempts, they would use a stack canary that had a byte that was 0, which would represent a null, a byte that was 255 hex FF that could represent an end of file in certain circumstances. And they would have a couple of other special values, such as Control C or Control D, to get various functions that would look at those particular bytes and say, oh, that's a terminator of some sort. Let me stop my stir copy, for example, if I see a null byte, 00. And that was somewhat successful, but very quickly people found a way around that. And so some others decided to go one step further. And what they did is they changed the way the compilers work. So the compilers will actually rearrange the stack. And what they'll do is they will make copies of certain local variables and parameters, and they will use those copies rather than the actual parameters in the methods as far as what is on the stack. What does that do? Well, if I have a value that is risky, something that needs to be protected from being overwritten, such as a return address, I want to put that value after the canary so that I can tell if you tried to overwrite it. If I have only copies of the parameters that I use, and I put those after my canary in higher memory values, I can't overwrite things that are in the low memory values. And that's sort of the whole idea behind the stack protector. It uses a combination of things. So if you look into it in detail, what you'll find is that different portions of the stack have been rearranged. In other words, instead of having your parameters in a certain order, they might become reordered by the compiler. And again, they will have copies of the parameters placed on the stack. And that is why things look a bit different here. So if I rerun my program in GDB, now this time I'm going to add to it. I'm going to run it again. And it says, do you want to stop this program? And yes, I do. And here I am. I've gotten to my breakpoint. Once again, I will look at my stack. I find my values in a reverse order, and I suspect that this program is going to become very unhappy soon. So how do I continue running this program now that I've gotten to my breakpoint? Well, there are a couple of options with GDB. I can step one line of code at a time using step. I can also step one assembly instruction at a time using step I, or I can just continue. Now, as with most commands in GDB, as long as it's not ambiguous, I can use tab completion. If I say continue here, it's going to immediately die. It's going to say, program receives SIG abort, aborted. And again, it printed out my message, stack smashing detected. All right, a little bit more about GDB before we finish up this video. GDB allows us to examine things. Again, if you need help, you can type help. If you want to get help on a specific command, you can type help and the name of that command. and I can type help X, and it tells me a little bit more about how to use it. We previously used the info command, and I can use info on functions, and it will tell me the functions in my program. I can also do an info on registers. And notice here I have quite a few registers defined, again, because it's a 64-bit machine. But one of those registers is RSP, and another one of those registers is RBP. Another important one would be RIP, the instruction pointer. Notice they all have very similar addresses. They all start with 7FFF. I'm going to go ahead and quit here. That's all for this video. In the next video, we will continue our discussion of Linux stack buffer overflows.